Did you know that most students fail math tests because they can't tell the difference between a relation and function? Today I'm breaking down the one rule that changes everything. Relations, functions, domain, and range. These words sound complicated, but they're actually super simple once you see the pattern. In the next few minutes, you'll learn the vertical line test, how to spot function instantly, and how to find domain and range without memorizing a single formula. So if you want to ace your next math test, stick around because we are diving in right now. Let's go. Hi again and welcome to the second chapter of this module, which was about the relation, function, domain, and range. So if you guys remember, in the previous chapter we were talking about the relation and we talked about the specific kind of relation. We call it as a function. We had a test in order to find out that which relation can be considered as a function. Also, we had a little bit of talk about the domain. It means that the specific value or acceptable value that we can consider for x or input, and also about the range, which means that based on that specific value we have for inputs or x, what are the values we can consider for y itself. So let's continue. So after that, let's talk about another concept that we do have as finite at infinite cases. It means that at this point, rather than just talking about only about the range, we are going to talk about the limited input. So let's just look at it. We do have a finite domain. It means that at this point, I only can have the finite or just a specific amount of input for myself. It means that, for instance, at this point, I do have -2, 0, and 3, and this is my some kind of domain, so I cannot have any other numbers rather than this one. And obviously, based on this inputs, I can have some output. And also, we remember that based on each specific input, we only can have one specific output because that was the definition of function, right? So 3 inputs and probably 3 outputs. So after that, at this point, we know that you have to list a specific value in order to set the notation. It means that at this part, I do have 3 values. And it is mostly used for the data tables and discrete inputs. For example, at this point, we had -2, 0, and 3. On the other hand, we do have some points that we call it as infinite domain. It means that rather than just having specific numbers or limited amount of numbers, we do have a range. And in this range, since we do have all the real numbers, for example, between 1 and 2, there's infinite numbers or real numbers there, right? It can be anything, fraction, the decimals, anything, you name it. So at this point, we call it as infinite. So, for instance, I do have negative infinite to positive infinite, and at this time I do have the use interval. So in order those interval notations that we use it with infinite symbols. So this part is for the continuous range, and we do have the domain for that one. And it doesn't necessarily mean that this infinite should be infinite symbol itself. It could be from, for instance, -2 to positive infinite. By the way, when you don't have a sign beside the infinite itself, it means that the positive infinite. Right now, I do have a range from -2 to any number bigger than that. After that one, we do have the set with interval. It means that at the first point, we had the list of elements. And at another point, we do have interval notation. So what was interval notation? If you guys remember about the equations and inequalities, again, we had a separate video about that. On that point, I talked about this condition that in our equations, or I have to say inequalities, my x or variable can handle some kind of more than one number, or at that point, it can handle a range. So we do have the same condition over here. At this point, as you can see, I do have the interval notation for the first part, that I do have it as A and B, both of them are included, but we call it as a closed one, and A and B, or both of them are excluded, and we do have it as open one itself. So these 3 ways are the way that how we can talk about the domain of our inputs itself. After that, let's talk about the finite numbers. As I just told you, for the finite ones, we only can have specific value for our input. It means that they are countable. So imagine that I do have the x, I do have an input from -1, 0, and 2. I do have f of x, which I call it as a function, that it has a rule. That rules, I do have 2x to the power 2 subtracted by 3x plus 1. And based on this input, after putting them inside this function itself, I do have these 3 outputs. So I would call this the first 3 one as the main, and the second 3 I would call them as the range itself. So if I also can show it to you in a table itself, we are going to use that one in the future in order to draw a relation or function in order to see that how we can show it into some kind of x and y axis. Again, don't worry about it right now. We are going to talk about it in the future in detail. So as you can see how we reach out from -1 to 6 by putting it over here inside each terms of our some kind of expression and try to find that one. And 0 the same, 2 the same, and imagine we are going to add another number 3 and we are having this one. Again, this is the finite function. We do have limited set of inputs and each input is going to produce exactly one output or f of x. That was the definition of function. Both domain and range are finite some kind of sets itself. So let's look at a polynomial example. It means that this one I do have infinite numbers. So again, I do have the same rule. I do have f of x, 2x squared subtracted by 3x plus 1. And at this point, I do have a domain. My domain is going to be from -infinite, which is going to be over here. For example, right now it's -infinite and to +infinite. It means that at this point I can have any value that I want. So finding the range for this kind of condition, it would be a little bit challenging. Again, in the future, I'm going to talk a little bit more about that, especially about this kind of some kind of expression when some kind of related equation that we call as a quadratic equation. So how we can find the range itself? Our range is going to be small, is going to be bigger than or equal the vertex of the y itself. So how we can find the vertex? I'm going to show you the next slide. But imagine that I do have a point, which actually this one should be over here. Imagine that I do have a point that I would call the minimum amount of number that this f of x can have, as I call it, as a vertex. It means that there's a specific point, there's a specific x value. If I put it there, my y would be the smallest amount of possible. And also we know for a fact that y, if that, for instance, y was equals x to the, if it was y(x to the power 2, we know for sure that whatever number I can have the x, whatever number of x, my y should be positive, right? But at this point, you can see the number is not going to be positive. Maybe some of you would say that, okay, you told us whenever we do have the power of 2, our y cannot be negative itself. That's right. But right now, you see that rather than the number, the power of 2 itself, we do have -3x, and also we do have the positive 1. So probably the number would change. So let's see how we can find a specific number. We do have a formula for that. The x, or that is x value of that specific vertex or specific point, because we know each point should be declared using two things, x and y. For finding that a specific x, we had a formula. X is equals -b over 2a. Maybe some of you would say that, okay, what is b and what is a? Again, in the quadratic equation, we are going to talk about it in detail, but just so for FYI right now, whenever you have the quadratic equation, the way that you can declare that one is like that one. F of x is equals ax to the power 2 plus bx plus c. I will talk about in detail all of what does those coefficients mean, that what does those constant value means. But using this way, I can find my b, which from the previous example, my b was -3, and I also do have my a itself. A is the number beside of x squared, and b is the number beside x, and c is just a constant. So a is going to be 2, b is going to be -3, using that formula, and I do have a 3 over 4, or I do have 0.75. So what does that mean? Means that that specific value for the x part of the vertex itself is going to be 0.75. How I can find the y, or how I can find the f of x? Easy. The only thing I have to do, just put that specific number in the rule itself, and you can see my y is going to be this number. It means that right now, whatever value that I put into my rule or into my f of x from -infinite to +infinite is going to be for sure a number from negative of 0.125 to +infinite itself. So by this way, I can find the range of y with a very, very simple tactic, which means that I can find the x part of the vertex, or we can call it as a vertex point, use it inside f of x, and after that I can find the minimum amount of y, and I know for a fact that since this curve is like this, again I will talk about it, why the curve is like that, and why is not like this, or why not like that, don't worry about it. So we know that for a fact it's going to be minimum value to +infinite. This way I can find my range itself. So we do have a couple of mistakes that you have to make sure you're not going to have them. The very first thing is that sometimes you're going to confuse between the input repetition with output repetition. Again, I told you, when we are talking about the function, the only time that we can consider a relation as a function means that each specific input should be just aligned to a specific output. For each input, you should have one output, but it doesn't mean that for one output you cannot have two. You cannot have two inputs. If you guys remember from very previous example, or from the very first example, we had a curve like this. Let me use another color. We had a curve like that. Oh my god, it's not that good. We had a curve like that, and I told you that if we just some kind of like this, we had a curve like that, and I told you if we test this one, or test our vertical line test, we can see that this guy is a function. But at the same time, I do have two x's that is going to have the same number or the same output. That is completely fine. But when you have some kind of one input and it's going to give you two different outputs, that's a whole another story. So try not to get confused with that. Another thing is that you have to, sometimes you're going to ignore restrictions. Division by zero, square root of negative numbers, logs of non-positive. And if you remember, we had a definition that we called as the domain itself. Domain means that all of the acceptable values that we had for x. The range was all of the values that we had for y. So whenever you saw a condition that your variable is in the denominator itself and putting any number could make one of this prohibited condition, that means that, for example, 1 over 0, or you have there some kind of radical or square root and you have a negative number beside that or beneath that, it means that it's not acceptable itself. So be careful about that. And at the end, you're going to mix about the domain and range again and again and again. Domain means that whatever number that's going to be acceptable for my x. Range means that whatever number is going to be acceptable for my y itself. So let's see a couple of examples. So at this point, we do have input-output confusion. So I talked about it. It means that multiple x values to one y is not a function itself. So be careful about that. One x value to multiple y values is not a function. So try not to get confused. I talked about it. Missing the restriction, I talked about that one. It means that, for instance, when you have f of x is 1 equals to 1 over x, and if somebody asks you, okay, what is the domain itself, you will say that, okay, that's easy. It's going to be all real numbers. But remember, again, 0 is a real number. So 0 cannot be a number itself. And at the end, just try confusing between values of the domain and the range itself. So let's look at an example, and it's going to be final example for this chapter. So I do have a circle. Again, this is going to be considered as a function or not. If you guys remember, whenever we have this condition, we have to just find one vertical line that based on that, my 1x is equal to give me 2x. So if you have something like this one, you see that for one specific point, you have one y and you have the second y. So this guy cannot be a function, but it can be considered as a relation. After that, we have to evaluate the g of x is equals to x minus 5. So it's easy. The only thing that you have to do, use the substitution method. What was that? It means that instead of just the variable itself, you have to use a number. So at this point, I do have negative 2. It would be 2 times negative 2 subtracted by 5, and you have your final number itself. And identify the domain means that h of x is equals 1 over x minus 4. So the very simple way that you can do that is, for a fact that you do have a variable in the denominator itself, and you have to make sure whatever number that you put inside this rule or inside this function is not going to give you one prohibited fraction, which we know it as 1 over 0, which is undefined. So at this point, 4 is a prohibited number. So at the end, if someone asks you what is the domain, you would say that it's all of the real numbers except number 4 itself. So guys, that was everything related to this module that we talk about the function, relation, and also about the domain and range. Please be careful. Try to some kind of look at the whole video again to completely understand everything that you had. There are 2 different videos. And again, if you have any problem, you can just comment down below for me and I can help you with that. If I couldn't, I'll probably make another video to have more examples. Again, please like, share, and comment. That would be so helpful to me. This is Matt. Have yourself a great day, night, whatever. See you around.